Designers, programmers, and end users see data in different ways. Different views of same data lead to designs that do not reflect organization's operation. Data modeling reduces complexities of database design. Hello everyone, this is Miss Karen. In this module, you will learn about data modeling and why data models are important. At the end of the lesson, you should be able to define data modeling, identify the basic data modeling building blocks, explain why data models are important, and create an entity relationship diagram. The data model. A data model is an abstract way of describing how data are organized. A data model represents a framework of what the relationships are within the database. This framework, in the world of data warehousing, is a critical component as it will provide the structure which will support the analytical needs of the decision makers. The data itself will be literally stored within this framework of the database. Building a data model is a critical step in the design of the data warehouse. Why data models are important? First, data models facilitate interaction among the designer, the application's programmer, and the end user. A well-developed data model can even foster improved understanding of the organization for which the database design is developed. In short, data models are a communication tool. Next, end users have different views and needs for data. Data constitute the most basic information units employed by a system. Applications are created to manage data and to help transform data into information. But data are viewed in different ways by different people, so that there is a huge importance of data modeling in DBMS. Next, data model organizes data for various users. What is an entity relationship model? ERM is widely accepted standard for data modeling introduced by Chen in 1976. Data modeling is a graphical collection of logical constructs representing the data structure and relationships within the database. An implementation model would represent how the data are represented in the database. The ERD or Entity Relationship Diagram uses graphic representations to model database components. The entity which is part of the ERD is mapped to a relational table. The ERD consists of entities, relationship among entities, and attributes of both the entities and their relationship. These are what we call the data model building blocks. First, let us discuss what is entity. Entity is anything about which data are to be collected and stored. This can be a person, a place, object, event, or concept that we want to store in our database. An entity is represented by a rectangle. Examples of entity. For person, it can be an employee or a student. For place, it can be a store or a warehouse. For object, it can be a machine or a building. For event, it can be a sale, registration. For concept, we have account or course. We have our example here, student and subject. These are both entities. An entity can be categorized into two types. It can be strong or weak entity. A strong entity exists independently of other types of entities. It has its own unique identifier, which is the primary key. Later on, we will discuss what a primary key is, and it is represented by a single line rectangle. A weak entity is dependent on a strong entity. It cannot exist on its own, and it has no business meaning in the ERD without the entity. It does not have a unique identifier, only partial identifier, and it is represented by double line rectangle. In this ERD example, can you identify the weak and strong entities? The strong entity is the employee and the weak entity is the dependent. The dependent here can be the parent or child of the employee. The dependent cannot exist without the employee, which is the strong entity. In identifying relationship, the weak entity is always connected with the strong entity, and it is connected by a diamond, which is the relationship. When we connect the strong and the weak entity, we use a double line diamond. Next is attribute. An attribute is a characteristic of an entity, and it is represented by an ellipse. So examples of attributes of the entity student are name, ID number, address, and birthday. The unique identifier of student is the ID number. There are two types of attribute. It can be a composite attribute or a derived attribute. When we say composite, the attribute is broken into component parts or several parts. An ellipse is connected to the several ellipses. For example, we have address. The address is a composite attribute since it can be broken down into several components like street address, city, state, and postal code. Whereas derived attribute is an attribute whose values can be calculated from related attribute values by a line. In this example, the derived attribute is years employed. Years employed is derived from the date employed and the current date. Another example of derived attribute is employee's age. Another example of derived attribute is age. An age can be derived from the attribute birth date and the current date. What is a primary key in a database? A primary key is an attribute or a combination of attributes that uniquely identifies an entity or a table. It is represented by underlining the attributes involved. For example, employee ID is the primary key in a table employee or in an entity employee. Characteristics of primary key should be unique and it should be not null. The next data model building block is relationship. Relationship describes an association among the entities. It is represented by a diamond-shaped symbol. A relationship can also have attributes. For example, the entity student enrolls in a subject. You can identify that the verb is the relationship and the noun in a business rule are the entities. We have learned that relationship is a meaningful association between or among entity types. In this ERD example, an employee completes a course. An employee has a unique attribute called employee ID. So this is the primary key. It also has attributes name and date of birth. A course also has a primary key called course ID, which uniquely identifies the entity course, and we have title and the topic. Relationship instance is an association between or among entity instances. In this example, these are instances showing how many courses the employees completed. Attributes on relationship. Attributes may be associated with many-to-many or one-to-one relationship as well as with an entity. In this example, the date completed can be an attribute of the relationship completes. These are also instances showing the date the employee completed each course. In an entity relationship model, there are numbers of entity types. There are number of entity types that can be attached to a relationship. These are unary. This can be unary, binary, and ternary relationship. What is a unary relationship? It is a recursive relationship within a single entity. In this example, the entity person can be married to another person. So this is a unary relationship. In binary relationship, it is an association between two entity types, and it is the most common relationship. In this example, the entity student can enroll in an entity subject. A ternary relationship is an association among three related entity types. In this example, each vendor can ship part to a warehouse. There are three types of relationship that can exist between the occurrence of related entity types. First is one-to-one relationship, one-to-many relationship, and many-to-many relationship. In a relationship, we have a cardinality constraint. Cardinality is the count of instances of one entity that are related to the instance of another entity. Constraints, however, are the rules enforced on the data columns of the table. These are used to limit the type of data that can go into a table. One constraint established in relationship, it limits the number of entity occurrence that are associated in a relationship. We have maximum cardinality and minimum cardinality. By means of maximum cardinality, it is the maximum number of entity instances that can participate in a relationship. This can be one-to-one, one-to-many, and many-to-many. Minimum cardinality is the minimum number of entity instances that must participate in a relationship. It can be categorized into 0 means optional and 1 means mandatory. In minimum cardinality, there are two types of relationships. It can be optional and mandatory. Optional relationship states that an instance of one entity may not be associated with an instance of the related entity. The minimum cardinality is 0. While mandatory relationship, every instance in one entity type must be associated with at least one instance in the related entity. The minimum cardinality is 1. The symbol used for mandatory relationship can be seen here. For mandatory 1 cardinality, in Krauss-Foot notation, we use double line. For mandatory 1-to-many cardinality, we use a Krauss-Foot notation like this. For optional 0 or 1 cardinality, we add circle and a single line. For optional 0-to-many, circle and 2 slanting lines. In linking relationship from one entity to another entity, we use entity relationship notations. Relationships are expressed using chain notation or Krauss-Foot notation. So in chain notation, we use alphabetical and numerical symbols like 1, M, and N. For one-to-many relationship, for example, a painter can paint many paintings and each painting is painted by one painter. It can be portrayed in ERD like this. One painter paints many paintings. In Krauss-Foot notation, however, these symbols can be used. In Krauss-Foot notation, this is the symbol for one and this is the symbol for many. For many-to-many relationship, in this example, an employee can learn many skills, and each skill can be learned by many employees. So this is M to N. We use many-to-many as M and N, while in Krauss-Foot notation, this is the symbol for many-to-many. In one-to-one relationship, an example, an employee manages a store, and each store is managed by one employee. For Krauss-Foot notation, one employee manages one store. You can use either of the two notations. We cannot use both notations in one ERD. If you used chain notation, you just apply chain notation to all ERD. However, if you use Krauss-Foot notation, you must use Krauss-Foot in all your ERD. As discussed in the previous module, business rules are descriptions of policies, procedures, or principles within a specific organization. Sources of business rules are from company managers, policymakers, department makers, department managers, written documentation like procedures, standards, and operational manuals, and direct interviews with end users. This is how you can get business rules to apply in your database. How can we translate business rules into data model components? First, we identify first the nouns in the business rules. The nouns there are the entities. Next is to identify the verb, which is translated into relationships among those entities. Next, relationships are bidirectional. Next, we identify two questions in the relationship type. How many instances of B are related to one instance of A? And how many instances of A are related to one instance of B? Here we can know the relationship type, if it's one-to-one, one-to-many, or many-to-many, or if it's optional or mandatory relationship. Okay, what are the naming conventions? Naming occurs during the translation of business rules to data model components. Names should make the object unique and distinguishable from other objects. Names should also be descriptive of objects in the environment and be familiar to users.